In today's lesson, we are going to look at limits. So this is going to be a little bit of a new concept from what you've learned in the past. And again, it is just a concept, so don't worry too much. It's not going to be like a heavy calculations. So kind of in par with the last lesson, it's more about just learning a new concept rather than calculations. So just as a warm-up, one day Josh ate half a pizza. The second day he ate half of the leftover pizza. Should be the third day. The third day, he ate half of the pizza left over from the previous day, and so on. We want to show how much pizza remains after each day for 5 days. So we've got a table kind of started. So the first day, he has a full pizza, he eats half of it, so he has half a pizza remaining, and he's eaten half a pizza. The next day, he has half a pizza, he eats half of it, so he's left with a quarter. Right? So he's eaten right now 3/4 of the pizza. The following day, he has a quarter left, he eats half of it, he now has 1/8 of the pizza remaining. So that means that he's eaten 7/8 or 0.875 of the pizza. The fourth day, he has 1/8 of a pizza remaining. He eats half of it. He has 1/16 of the pizza left, meaning he's eaten 15/16 of the pizza. Or we might say it is 0.9375. On the last day, he has 1/16 of the pizza left, or on the fifth day, sorry, he eats 1/2 of it. He has 1/32 or 32 of the pizza remaining. So he's eaten 31/32s, or 31/32s. 31/32 is what's been eaten. Or in other words, 0.96875. So that's how much pizza he's eaten and what's been remaining. We want to take a look at the amount of pizza eaten and the day number, right? So each day, and graph it to see what it looks like. So on day 1, we have half the pizza remaining. Day 1, half the pizza remaining. Day 2, again, we have then a quarter, or not, sorry. Day 2, we have a quarter of the pizza remaining, 0.25. Day 3, we have 1/8 or 0.125. Day 4, we have a 1/16 or 0.0625. And day 5, we have 1/32 or 0.03. So that is the amount of pizza remaining. If we want to graph the pizza left or eaten, right, we would also have half on the first day, so half the pizza was eaten. On day 2, we have 0.75. Day 3, we have 0.875. Day 4, we have 0.93. And on day 5, we have 0.96. We have two different kind of versions going in opposite directions for pizza remaining and pizza eaten. So we want to look at, we didn't have it in there. We want to kind of graph it. We want to take a look at what can we say about these values? What can we say about these values? Well, looking at these values, we can say that the pizza eaten in red, we're getting closer and closer to eating the whole pizza. Or these dots are getting closer and closer to 1. The blue dots, the remaining pizza, is getting closer and closer to 0. Now, are we ever going to reach the end? If Josh keeps this up, is he ever going to have no pizza remaining? Well, technically, no. Technically, he's always going to have some bit of pizza remaining. He's never going to not have any pizza remaining, because if he keeps on taking half of a half of a half and so on, he's going to get smaller and smaller pieces, but in the end, he's still going to have a piece. It's going to be a very small piece, but he's never going to get to the very end. Same with the pizza eaten. He's going to get closer and closer to eating the whole thing. However, in the end, because there's still always going to be some remaining, he's never going to eat the whole thing. So this is what these numbers are, or what the pattern is, or where these numbers are heading. This is kind of what we call our limit. And limits, by definition, the limit of a sequence or the limit of numbers or the limit of a graph is determined by looking at where the y values are going. Right? Where are the y values headed? Right? Or where are the values headed? So that's what we were looking at today. So for example, I have a graph here. I have my table of values. Graphically, I can see it. Right? You can take a look at the pattern in the numbers in the y values and see what's happening. But where are the y values going? In other words, what is the limit of this sequence? Well, they start at 27, they go down by a third, and we get to 9. They go down by a third, or they divide by 3 again, we get to 3. Divide by 3, divide by 3, divide by 3. Similar to the last one, instead of dividing by 2 every time, we're dividing by 3 every time. So in this case, we are getting closer and closer to 0. The next part asks, will the y values ever reach that limit? So if we keep on dividing by 3, are we going to ever reach 0? And similar to the pizza question, no, we're not. Right? We're going to get very, very close, but we're not going to reach 0. This next example looks at, it's basically a graphical representation of what you might say is radioactive decay. Right? We're looking at a certain amount of radiation or material that's left over, and every 6,000 years, it decreases by half. So we lose half of it, or half of it becomes not radioactive anymore. And the pattern continues. So again, the question is, where are the y values going? What is the limit to the sequence? Right? So if I keep on dividing by 2, 75 divided by 2, 36.5. Can't do math right now, or can't do it quickly in head. 37.5, I was close. 37.5, then 37.5 divided by 2. 18.75, and so on. We keep on getting smaller and smaller by halves. Right, so where is it headed? This is very similar to the pizza question, except obviously starting off at a much higher value. But we are headed towards 0. So again, the limit to the sequence is 0. Will the y values ever reach the limit? Again, no. Right? The point of the limit is where the values are heading towards, and they're never going to really reach that limit. They're never going to hit it. Next, we're looking, maybe we're looking graphically at positions in tiles, right? If we have a pattern or number of squares, and we're looking at every position number, we see what's happening. So in this case, we're adding 6 every time. 6 plus 6 is 12, then plus 6 is 18, and 24, and so on. So graphically, you can see that. Now, where are the y values going? What is the limit? Well, if we keep on adding 6, we're going to get higher and higher and higher and higher. We're going to keep on getting larger. So in this case, the limit is infinity. Let me draw a better one. The limit is infinity, right? These values are going to keep adding 6 continuously till infinity. Right? So similar, a little bit different from the other ones. The other ones were heading towards a number. This one is heading towards infinity. Another example, this one might be a little bit more challenging, but if we look at our table and our graph, we want to continue this sequence and look at where the values are headed. Right, so first one, we have a half, 2/3, 3/4. What's the pattern? Well, if you think of the pattern, it'd be 4/5, 5/6, and so on. So basically we are increasing the denominator by 1 and increasing the numerator by 1. So we are basically getting a smaller, we're basically decreasing what's missing, you might say, or it's very similar to, kind of similar to the pizza question, where we're always missing just one piece, but the size of the piece is getting smaller and smaller. So what is it heading towards? And we can see it graphically here as well, right? So 0 is here, 2 is up here, 1 would be here. Where are the values headed towards? Well, we're basically getting closer and closer to a whole or a full or a whole fraction, or not a whole fraction, basically getting closer and closer to a whole or 1, right? If you think position 99 would be 99 over 100, right? We're almost there. We're almost there, right? We would probably have 999 over 1,000. That's very close to 1. So the limit of this sequence is 1. Again, is it ever going to reach it? No, not based off of this pattern in the sequence, but we are going to approach it and get very, very close. Here, we're going to look at a sequence of numbers. So -5, -10, -5, -10, -5, -10. Right, so you might see it as, it might appear as dots, right? Because it's only singular values. It's not lines. It's not all the values in between. Right? So this sequence of numbers. Right? What is the limit? What are these values approaching? This one's a little tricky. It has to make you think a little bit. Are they approaching anything? We can't say they approach -10 because, well, here we reach -10, but the other values aren't headed towards -10, right? They're at -5. Right? As soon as I hit -10, I go back to -5. So I'm not approaching -10. I'm also not approaching -5 because, again, as soon as I hit -5, I go to -10. So in this scenario, there is no limit. Right? The numbers aren't approaching anything, which is okay. Right? Normally, in terms of graphs, we don't really, there usually is a limit sometimes, whether it's infinity or a specific value. Sequences, it depends. We have to look at what the sequence is and see if there's a pattern where the numbers are headed. If there is no pattern, or it's a repeating pattern, then there's not a limit. So again, the main thing from this lesson is, we'll just go back up to the definition and end on that, is just understanding what the definition of a limit is. And if we look at a sequence of numbers, or if we look at a graph, or if we think of a scenario, can we determine what the limit is? Or in other words, can we determine where the y values are going or are headed towards?